Our sorbent is extremely happy to get CO2, and it doesn't actually capture much other things apart from some water. So we actually supply water as well in our process. However, you can never have perfect vacuum, and our desorption runs in vacuum, which means that there will be some traces of the surrounding air that will also come into the output CO2, and that means that there may be traces of whatever was in the air around it. So, for example, if you would have very polluted air in the traffic, you would likely find some of the traces of that in the output as well that we would supply. And so that's why it's a philosophical question that we're having on like I was just thinking about earlier today, is capturing CO2 or are we purifying the CO2? And if we're capturing CO2, then it's like, okay, I want as much CO2 as possible. But if we're purifying it, well, we have to have as little of trace oxygen, for example. A lot of times, if you're going to use the CO2 for a catalytic process, you may have a catalyst that just degrades very quickly if there's oxygen in it. So those are things that we are dealing with, and that's why also I think what Trevor was speaking about is quite interesting. We see some of the processes for large-scale CO2 storage being kind of designed for post combustion capture, where there's like a lot of standards around. You have to prove that you don't have any NOx's or VOCs, for example, but they're not really that relevant if you're capturing from the air. So it's an interesting to look at how do we optimize that. At the end of the day, right? The technology exists, and we can do. But the proof point is, can we make this cheap enough that whatever is left to getting parity with fossil fuel CO2, we can actually get incentives for, or we can compete with, we can take out the transport costs. So we can actually make this happen without being too dependent on very generous incentives, So that's why I think it's a kind of a cross-industry job to come out with not just solutions, but also standards and requirements that enables this CO2 capture from the air to take a bigger chunk of both CCU and downstream CDR and power-to-X processes as well.
Sure, thank you, Bjorn. And let's pull you in here for a moment, Trevor. You talked to us already about some of those impurities that you're identifying and helping to tackle. So what are some of the most common impurities that you find?
Yeah, so again, the priority species are the NOx and SOx. So a majority of my research is centered around those for the pipelines. We've seen like the Aramis specifications, a good example out of the Netherlands, decreasing those metrics lower and lower. And I know there's continual research in specifically those components, and then moisture as well within the CO2, those specified limits are consistently decreasing as well. So I would say those would be the three. And then there's also potential for breakthrough components from whatever capture technique is used as well. And yeah, I know it's going to be very industry based on these impurities, but I think for these hubs, it's a concern is these impurities and the large mix of them that could be present.